problem sometimes by, we have a curve
Are you done, Rod?
and we can break it up into little rectangles and then calculate the area.
I'm sorry. Is it right here?
But that is only an approximate area. Okay, so what we're gonna do is try to find the exact areas, and we can do that by integration. And that's what we're gonna do. So I'm gonna do this example for you right here. Let me put some graph paper on here. Show you something. This is in the book. If you have a book, it's on 412, but if you don't, you can probably see it. Can you hear me okay?
Yes.
Okay.
Does she have a bottle right there?
It just came through
Is it
here.
empty?
It is. Okay. It's kind of a crude drawing, but okay, so we have this curve, and let me give you the curve.
Okay, maybe look at her. She's laying there.
This is example 2 on page
Okay, come here. Okay, later.
12.
You just don't. Shh, gotta be quiet.
Okay, so if we had a curve, let me see if I can draw the curve a little bit better. It's kind of,
Just make sure the blanket's not in her face.
boy, that looks a little bit nicer. And they wanted to find the boundaries of this thing from -1 to 2. All right, so from here. So they're not looking for the area under the whole curve. They're just looking at this. Let me do this.
Bless you.
They're looking for this area right in, whoa. That came out.
Fancy.
I don't know what happened there. Okay. There we go. All right, so they're looking for this area right under here. So the way we would write the problem is like this. This is a little different from the way they wrote it in the book. We usually put the upper bounds here and the lower bounds here, okay? So we read it out like that. Okay, now what we're gonna do is take the integration of this. So what would this be if we integrated it? What about x squared? What would that be?
X to the 3rd over 3.
Right. And what about 1? That would be 1x, huh? Or just x. Okay, so these get bigger, you know, the powers get increased. So this was a 2, now it's a 3. This had no x. Actually, you can think of it as x to the 0, and now it's x to the 1. So, you know, you can think of it that way. And we're going to go from 2 to -1. So what we're going to do is we're going to substitute the 2 into this first, this problem right here. And here we're going to substitute the 2 in there. And instead of rewriting, I'm just going to put down. So 2 to the 3rd, of course, would be 8 over 3 plus 2 minus this whole thing minus, and now we're going to put a -1 in here. -1 to the 3rd over 3 plus -1. And that should give us the area under this curve. Let's see if it works. 8/3 plus 2 minus, this would be a negative 1/3. But we're going to distribute this minus sign to it, so it will actually come out a positive 1/3. And this would give me a positive 1.
Mr. Mitchell, we can't see.
You can't see this?
The bottom half of it it's too zoomed in for us to see.
No, that's just on your screen, Bradley.
Yeah, I can see.
Oh, look
Can
at
you
that.
see it,
Thank
Wakaba?
you, guys.
DJ?
Yeah, I can. I figured might as well.
Are you
No,
okay?
I'm just in Australia.
Okay. All right, well, anyhow, if you add 8/3 and 1/3, you get 9/3, which is 3. And 2 and 1 makes 3. So altogether, this should add up to 6 units. And that's what they came up with. So this is, rather than writing it out the way they did in the book, this is how we normally write this. Okay. So in this section, what we're going to do is find the area under a curve up to the x-axis, but we are also going to try to find areas where two curves intersect and try to figure out the area inside those things. So we're also going to do that. Yeah, and it's pretty much the same thing. It's not super hard. It's just getting used to the integration. The integration is a lot different from the differentiation, huh? All right. So we got this chapter kind of ended at 412, but if you notice, it just keeps going on. Okay. So we're going to try some more. We're going to kind of keep going. On page 413, they kind of show summation. We're not going to worry about summations. We don't have time to do all that. So we're going to go to a problem on page 416, example 7. EX7. 416. If you have a book. If not, the problem, I'll write down the problem. The problem is that we don't want to do that one. Okay. Excuse me, I didn't want to do that one. Let me go to example 8. I don't want to get into the A's and B's and all that stuff. Okay, so let's do this one. We want to go from, if you notice the curve is kind of a goofy little curve. The problem is this. Why don't we write down the problem first of all? It's 2 to negative 1 or negative 1 to 2. You could read it that way. Of negative x cubed plus 3x minus 1. Make sure I get the signs right. Bradley, you disappeared. Who's on is
Yeah.
okay. I can't separate you guys. I don't know, like you're one person gets on top of the other person. There's probably a way to do that. I just don't know how to do it. So I don't want to mess with that right now. So anyhow, this is the problem, and this is what the curve looks like. Just a rough sketch of it. It's kind of a weird looking thing. We want to go from negative 1 to 2. And the curve actually comes down like this. And then it kind of comes back up like this. And then it looks like it turns before it gets to that. So what we're doing is we're computing different things. Okay, we're computing this area and this area. We're computing the areas under the curve. But then I think we have to subtract off this area here. So it's kind of a weird little problem there. We're not counting in this area. It's the area under the curve. So anyhow. So whatever it is, we're going to just take the first derivative of first integration of that. So that'll be a negative x to the fourth over 4. Still going to stay negative, plus 3x squared over 2 minus x. And that's why people love integration so much. Substituting that in, and then take away the bottom. So it's the calculation of the top minus the calculation of the bottom. Okay, so this would be negative 2 to the fourth. See, the negative is on the outside. So this would still be negative. It's going to be 2 to the fourth, which is 16, but it's still going to be negative 16 over 4 plus 2 squared is 4, 4 times 3 is 12 halves, right? Minus 2. Are we good on that? This whole thing minus, now we're going to put the negative 1 in here. Negative 1 to the fourth is positive 1, which becomes a negative 1. Negative 1 to the fourth, negative 1 squared is 1 times 3, 3 halves. And we put a negative 1 in here. Negative times negative is a positive 1. So this is going to be negative 4 plus 6 minus 2 plus 1/4 minus 1.5 minus 1. Let's see if we get it correct. It should give us a negative 2 1/4 if we calculate. These will come out negative sometimes because this is below the thing. So let's see if it does. This would be, well, these would cancel out. And we could change this 1/4. I mean, the 1/2 to 2/4. So that's a negative. I'm not coming up with that. Oh, yeah, because this is positive 1/4. That's a negative 1 1/4 minus 1. Yeah, would be a negative 2 1/4. Yeah, it works. These all added up to 0. And 1/4 from 2/4 is 1/4. Negative 1/4, negative 1, negative 2 1/4. Good. Okay, let's see if we can get another one that's, I guess in the next section, we have the two curves intersecting each other. So that'll be on the next group. Well, maybe it is in here. Let's see if we got any of those. Yeah, I think those are more in the next section. Okay. So let's look at your quiz here and see what we can do. We can also use these for actual problems. If I'll show you some problems that you can use these for, more like physics problems. Okay, so look at your quiz here, 4.38.
Did you send out an email with that quiz?
Did I send out what?
Okay.
If by chance, okay, if by chance you don't get the attachments coming through okay or anything like that, we do keep extra copies in front of the school. So we do put them in a box. It'll be labeled and they have extra copies. They don't have your name on them, but we do have extra copies that you can pick up. So if you lose your attachment or something and you need the paper, we do run them off too. The secretaries here run them off. They're really nice people. The one that looks really terrible is number 7. Let's look at that problem. Probably not as bad as it looks, but let's see if we can figure that one out. Can you see the screen okay now, Bradley?
Yeah. Sorry about that. I was zoomed in for some reason.
Oh, no, that's okay. Does a pen move real fast or something like that? I can't tell when I actually can't see what I'm, sending out. And it's a little, the reason sometimes it's a little shaky is because I can't see what I'm writing. I can only see it on my screen. So, you're used to looking at your writing on paper, but you can't, it's a little weird. Okay,
looks
so
pretty
what we're
good.
gonna do here is we're gonna actually distribute this out before we take the integration, kind of simplify it. So you can see this x squared and this negative x squared are actually gonna cancel. Becomes a pretty easy problem because x squared minus x squared, I don't know why they put this in a parentheses in the first place. You didn't need it. So this actually is only 1 dx. It really turns into a very simple problem. Well, for me. Okay, so then what's the integration of 1?
X.
X. From 3 to 1. So it's just 3 minus 1 is 2.
I like that problem.
Yeah, we're gonna have to put that on the final. Huh? Yeah, that one doesn't look too bad. I don't know about the finals. We're still kind of up in the air. They said they wanted a final, but then they said if you have enough to evaluate the student on without the final, we can maybe do that. And then they said they don't want us to use the regular course final, that we have to develop a different final. So I don't know. That's a lot of work. So I was thinking multiple choice. I just I want something that's easy to grade. I'm sorry, but we might have it. We probably have enough evaluations already here that we could evaluate students on. We got like 28 quizzes or something like that. There's plenty of quizzes, and these quizzes now that you're turning in are worth 40 points. Rather than 50 because we're not turning any assignments with them. So they're worth 40s. And most of you have been getting like on an average of 37 out of 40, which is an A, Most of you been doing a very good job. I'm gonna have to figure out a way to get you your grades without everybody seeing your grade, So I'm working on that too. I'll get back with that. I know you're interested in how am I doing. Well, with the high school, it's not so bad. We can maybe put it, go up to the high school and enter it into their computer on the parent link or whatever they call that.
Family link.
Family link. We could probably do an upgrade on those and put it in. Maybe the end of this week I can get up there. Okay, the extra credit one. Let me show you that extra credit one. DJ, you're upside down. Are you doing all these problems upside down?
Yes, I am.
What is this thing? What is this thing? You want to rate?
Chris, you disappeared, man.
Bradley's back.
Guys, they're upright.
What is that?
They're perfectly upright.
Huh. Anyhow, it says an object is moving, so the velocity after t minutes is velocity of time is equal to 1 + 6 t squared meters per minute. How far does the object travel in the 4th minute? Okay, so basically you're taking the integration of 1 + 6t squared dt. Okay, so that's our integral, but they want to know how fast is it going in the 4th minute. So what we want to do is we want to calculate between the 3rd and the 4th minute, like that. And that'll tell us how fast it's going in just that 1 minute interval between the 3rd and the 4th. From the 4th to the 5th, it's going 0. It's already crashed into the earth. So we want to know how fast this is going between this amount of time. So it's really not too hard of a problem. This will give us t, we'll just call it t, plus, and this is going to be the 6 stays, t to the third over 3. Is that the ice cream man?
No, that is my cuckoo clock from Holland that my grandma gave us.
That's pretty cool.
Thank you. It's got the big dangly weights
Yeah,
and
but
stuff.
it's like 9:25. Why would it ring at 9:25?
It thinks it's 9:30.
Yeah, but they ring like 9 o'clock, 10 o'clock.
This one does it on the 30s as well. We probably need to adjust the pendulum, but it thinks it's 1:30.
All right, well, as long as you're okay with it, I'm okay. Okay, did you follow this? So they don't always have to be X's in here, you know, different letters. Okay, then we just substitute in. This part is pretty easy. Plus 4 cubed, what's 4? 64 times 6. 384.
What if we got rid of the 6, called it a 2, got rid of the denominator, and called it 2 times 64?
Yeah, a little bit easier one. Good thinking.
128?
Let's put a 2 over here. Okay, let's do it that way. Very good thinking. Somebody's not awake. Okay, so that would be 4 plus, this is 64, 128, yeah.
So it ends up being 132.
Minus 3 and 27 times 2, 54.
Yeah.
And the pins, 132 minus, how much, pins?
75?
75. Oh, that's the answer. Wait, this is 54. This is 357, huh? Golly, this pen. Sorry about the pen kind of doing its own thing. 75, yeah, would be the answer. So 75 what? Meters per minute. Meters per minute.
Can I get bonus points if I give it in meters per second?
No, I said how far does an object travel in the 4th minute? Oh, how far does it travel? You're right. How far does it travel? It travels 75 meters. You're right. And that's not the speed, it's the distance.
Can I get extra credit if I give it in centimeters?
I know how to put zeros behind a number. No. Okay, any others you want to see? Anything that might be a little tricky? Let's see if there's anything with an X in it. X to the -1. No. Just remember the old rule, e to the x is e to the x. And 1 over x is ln. To take the derivative of ln x, very difficult to do, the antiderivative. So we'll work on those. We have u subs to do next. U subs is a technique we have to use when the problem gets a little tougher than these. Right now, these shouldn't be too bad. You want to practice on these and get good at them. Is there anything else you want to see on this quiz? Well, let's try number 1, just to make sure everybody's on the same page. 4.3a, yeah. Is that the last quiz on this section, or was there another one? Yes. Is there any on the other 2 that you want to see? Any problems? This part isn't integration, you know, sometimes people get all, it's just a matter of just kind of following it. But this is kind of the basics where Newton and Leibniz kind of saw that there was a correlation between taking the derivative and taking the integration and kind of combining it, just kind of like we do with factoring and expanding out problems, foiling and factoring. They sort of correlation between it. Then they sort of correlation to physics, basically.
Physical physics.
Physical physics, yeah.
I like it. Physical
Would
figs.
you call this x to the third over 3 plus x from 3 to 0? And just that easy, huh? They just get bigger. And just remember, we don't put a c here because we don't need to. Okay, so that's 27 over 3 plus 3. And a lot of times they are 0, which means it's going to be 0 over 3. Oh, the pen just started misbehaving.
Or -0.
Guess you wouldn't have to do this whole side, but just again, say 9 plus 3 minus 0 is 12. Easy enough, huh? All right, so I think that's it for today. If you have any questions, kind of save them, and we're going to week 4. I have those out tomorrow. I'm going to actually have them out today. And they're pretty much the same thing we're doing right now. Not a whole lot of difference. Let's see what we're going to do next week. Maybe I don't have next week's rule. Here it is. We're going to do 4.4, properties of definite integrals and u subs. We're going to start on u subs, okay. And that won't be too hard. Pretty much the same thing we're doing right now. That won't be too hard. Be just areas between two curves that we're going to be working on, which is a little bit more complicated, but not too bad. All right, shouldn't be too bad. Hang in there. Who's this little guy over here next to you, Bradley? That's your brother?
This is my brother Matthew.
You got some other people there?
Yes. Also my brother Jackson.
I saw a bunch of people in there. Okay, have a good day.
All right. See ya.
You later.
Hey.
I am signing you out.